All right, welcome to today's explainer. We're jumping right into the deep end of the database divide. Specifically, we're looking at that crucial leap from the rigid world of SQL databases over to the wild, flexible frontier of NoSQL using MongoDB and Mongoose. Look, whether you're architecting the next massive streaming platform or you're just trying to get your head around modern backend architecture, understanding how your data actually flows and, more importantly, how it's structured is absolutely vital. So today we're moving way beyond theory. We're going to break down exactly how these technologies fundamentally change how we handle data.
Okay, here's our roadmap for this session. 1. SQL versus NoSQL. 2. ORMs and ODMs explained. 3. Structuring data with Mongoose. 4. MongoDB core terminology. And finally, number 5. Putting knowledge into practice. Let's get to it.
Starting off with Section 1, SQL versus NoSQL. Because to really get NoSQL, we've got to understand that fundamental database divide.
Think about a high-frequency trading firm, right, or a major banking system. They rely on incredibly strict relational data. Every single transaction has to be tracked in an unbending, rigid table format. SQL is absolutely perfect for this. It thrives on those rules. But what happens when you need to store wildly varying data types? I'm talking user profiles, massive image files, MP4 video data. You really can't easily cram all of that into a rigid table without it breaking down. And that is exactly where NoSQL shines. By using objects in JSON, NoSQL just drops that strict format altogether. It's totally non-relational. This flexibility is what allows tech giants like Netflix or Flipkart to manage massive, unpredictable data sets with incredible agility.
Moving on to Section 2, ORMs and ODMs explained. Let's see how this all connects to the actual packages we use to talk to these databases. So if you're working with those relational tables we just talked about, you'll be using an object relational mapper, an ORM, to handle that rigid data. An ORM is essentially your translator. When your Node.js backend needs to talk to a strictly formatted SQL database, tools like Prisma step in as this ORM layer. They map the objects in your code directly to the relational tables in your database. This ensures all those strict rules and relationships are respected, and the best part, you don't have to write raw manual SQL queries for every single operation. Conversely, for our flexible document-based NoSQL storage, an object document mapper is the package that bridges the gap. Think about it. Because NoSQL doesn't use tables, an ORM wouldn't make any sense, right? Instead, we use an ODM. And when you're using MongoDB, your go-to ODM is Mongoose. Mongoose lives right inside your Node.js environment. It takes your JavaScript objects and neatly maps them to the documents inside your NoSQL database. It's literally the vital communication bridge for non-relational data. Okay, Section 3, Structuring Data with Mongoose. Now we hit the core problem of NoSQL, which is how do you manage total flexibility? Actually, our source material hits us with this exact quote. MongoDB doesn't have any structure. And honestly, complete freedom sounds great on paper until you're trying to retrieve a user's email and you get a chaotic mix of strings, integers, and missing fields. Pure anarchy just doesn't work in production. On one hand, yes, having zero format requirements is the biggest advantage of MongoDB. You can throw literally anything at it. But when you're building an application that needs to reliably insert, update, and fetch specific user data, you absolutely need a way to enforce some rules. Otherwise, retrieving your data becomes a total nightmare. This is exactly where Mongoose swoops in to save the day. It acts as our hero by enforcing a schema and a model, so we can predictably insert and retrieve our objects without losing NoSQL's inherent flexibility. This three-step flow is everything. First, you start with your basic JavaScript object, just simple key-value pairs. Then, through Mongoose, you define a schema. This is your blueprint. It tells the database, hey, I expect a name, an age, and a salary here. Finally, you wrap that schema in a model. The model is what actually gives you the functional power to do things, to perform operations like creating or reading data. It's the best of both worlds. You get the blazing speed of NoSQL with the much-needed predictability of a structured format. Which brings us to Section 4, MongoDB core terminology. Let's build a clear mental bridge by translating those SQL terms you probably already know into our new NoSQL vocabulary. This translation guide is super important. What you used to call a SQL row is now called a document. And a SQL table? That's now a collection of those documents. If you have any background in SQL, anchoring your understanding to this simple mapping is going to save you a ton of confusion.
A single entry of data isn't a row anymore. It's a self-contained document. And you don't group those documents in rigid tables, you group them in flexible collections. Understanding these 4 building blocks ensures you know exactly how data flows hierarchically inside MongoDB. So at the base level, you have your documents. These are your core lists of key-value pair objects. Now, to make sure those objects aren't a total mess, you apply a schema, which is that formatting blueprint we talked about. To actually interact with that blueprint, you use a model. And finally, when you group all of these structured documents together based on their use case, like grouping all your user data together or all your product data together, you create collections. Because NoSQL objects hold all their key value pairs natively right there within the document, you can fetch data completely independently. You don't have to rely on the strict primary and secondary key connections that SQL requires. Think about how SQL works for a second. Tables are relentlessly dependent on one another. To find out what product a user bought, you usually have to query primary keys across multiple tables just to merge the data. MongoDB basically says, yeah, we don't need to do that because it's an object-oriented database. The document itself already contains the relevant key value pairs. You fetch it directly, entirely on its own. And that independence, that is exactly what makes NoSQL so incredibly fast and scalable for modern web apps. Finally, Section 5, putting knowledge into practice. It's time to transition from theory to real-world application. The source material notes that after grasping these core concepts, it's time to actually write some backend code. Theory is great, right? Knowing how things work is important. But true understanding and full-stack development really only happens when your fingers hit the keyboard. So our source sets up an immediate challenge. You need to build APIs using a file system and JSON. No front-end and no actual database needed just yet. Now, you might be thinking, wait, hold on, why aren't we using MongoDB right this second? Well, because to truly appreciate the power of Mongoose, you need to feel the friction of doing it manually first. You're going to handle core JSON data using basic file systems, just to experience raw APIs interacting with data without any of the extra abstractions. As we wrap up this explainer, I want you to consider the sheer friction of manually writing file system logic to read and write JSON objects. It's incredibly tedious, right? Now ask yourself, once you experience the pain of managing data completely from scratch, just how much faster and more powerful are you going to be when you finally unleash the automated, structured power of Mongoose on your next big project? Something to think about as you start coding. Thanks for joining me for this explainer, and we'll see you next time.